Alright, so let's finish up with an example using the general formula. Okay, so instead of being just in terms of the previous and only being able to go from one term to the next, I'd like to be able to just say, well, after 7 years, what's the value? Okay, so just at any particular point in time. So we'll look at the formula and then dissect it a little bit. So here I've written Vn, so the book value, is the initial value minus V0 times R times N over 100. Now this here, okay, is the total depreciation. Okay, so over the entire life of the object, whatever it is, that's the total that's going to be lost. Let's think about what this means. V0, so the initial amount times the rate. Remember, the initial amount times the rate, well, that's how much it's losing per year, times N, where N is the number of years, so that makes it the total depreciation. We can simplify that a little bit by taking that little part, V0 times R over 100, so the initial amount as a percentage. And we said, well, before we called that the yearly depreciation, so I can think about that as D times N. So again, thinking about this, this is the total amount that we started with, minus how much I lose per year times the number of years. So this gives me the total depreciation, which is how much the item is worth at the end. So if I take what it started with, subtract off what it lost, then I've got what it's currently worth. So let's go through a couple examples here. So I've purchased a lovely photocopier for $5,700, and after 5 years it's valued at $3,705. Okay, so it's lost $1,995 in those first 5 years. We're also told that its scrap value is $800. Okay, so when it gets to 800, at that point, it's not doing any more photocopying, but I can at least sell it off for parts. So, first thing I've asked here is, well, what is the flat rate of depreciation? So I've been told what it starts at, I've been told what it ends at. Well, how much was it losing as a percentage per year? Okay, so I'm going to kind of think about two ways to approach this problem. First, we're just going to kind of chuck it in the formula, see what we get, and then we'll kind of reason through how it works. So as always, I say, write out the variables and fill in what you know. Well, I know what Vn is. It's valued at $3,705. It started at $5,700. I don't know the percent it was losing per year, but I know it happened over 5 years. Let me actually just move this over for now. So I know my formula. My book value is the initial value minus the initial value times the rate times the number of years over 100. So at this point I can kind of blindly put in the values. 3,705 is 5,700 minus 5,700 times, well, R is what I don't know, times 5 over 100. Say, well, I've got a whole bunch of numbers and one unknown. At this point, I grab my CAS and solve. Okay, so let's do that. Let's grab the CAS, go to a calculator page, menu 3.1 to get solve. Okay, and then I need to type in my values. Alright, so I filled in my equation. Solve 3,705 is 5,700 minus 5,700 times R times 5 over 100, comma R. Pressing enter, I get that R is 7. Wonderful. So if I go back here, I get that R is equal to 7%. Okay, but as I said, let's also just kind of think about reasoning through this. So the total depreciation in this case, again, depreciation is how much I've lost. Well, if I started with 5,700 and I'm down to it being worth $37.05. That means I lost $19.95 over the life, or over the 5 years. So if I lost a total of $19.95, that means annual depreciation. Well, that means the total that I lost divided by 5. So my annual depreciation is actually $399. And then I can say, well, going back to my concepts with percents, 399 is what percent of 5,700? Well, that means what percent times 5,700 gives me 399. So solving this equation, we would end up with P is equal to 399 over 5,700 times 100, which is also 7%. Okay, so no matter which way you work through it, you find that the rate was 7%. Now, I want to write the general formula in terms of n. So basically what I'd really like is to be able to have a formula that looks like this, where I've got numbers filled in for V0 and for D. So I want Vn equals V0 minus Dn. I'd like to put a number in for V0 and a number in for D. Well, I know what V0 is. It was initially worth 5,700. So Vn is equal. So that means I need to figure out what my annual depreciation is. If you've done it through this method, you've already got it. It's sitting right here. It's $399. But if you hadn't already done that, saying, well, I know it's 7% of 5,700. 5,700 times 7 over 100 is $399. So whichever way, if you've done it through this method and you already had the $399, otherwise using the 7% to figure that out. So there's a lovely little equation. Instead of being recursive and being in terms of the previous value, it's in terms of n. So if I want to find the value after 6 years, I put 6 in for n. So now we're asked, I've got this lovely equation, let's put it to use. After how many years will it be scrapped? Going back to the question, remember its scrap value is $800. So essentially, when is Vn equal to 800? So let's put that in. That means that 800 is equal to 5,700 minus 399n. Rearranging this equation or using solve on the CAS. Okay, so entering that in, I get solve 800 is equal to 5,700 minus 399 times n, comma n. It gives me a fraction. You're saying, I hate fractions, give me a decimal. Alright, control enter. And I get 12.28. Okay, so solving this, I get that n is about 12.28. Now the question is, do I round down to 12 or up to 13? So it says, after how many years will it be scrapped? So this is where I kind of say to myself, well, after 12 years, has it reached the scrap value? Well, if it doesn't get to 800 until partway through the 12th year, okay, that means at 12, it's still above 800, which means it's not scrap. Whereas at 13, it will be below 800, so by then it is scrap. Okay, so the answer here is after 13 years. Because at 12, it's still above the threshold. It's not until it gets to the 13th year that it is scrapped, and it does specify after how many years. so it's not wanting to go through quarters or anything like that. Okay, so that's how we can use the general formula to solve some problems. Okay, so looking at kind of taking off that total depreciation instead of just the annual depreciation 1 year at a time. Here we are.